to solve another Leetcode problem. 1124, longest well-performing interval. So we are having an hours, and if the hour is more than 8, so it is well performed. So if it is less than 8, so it is not well performed. We want to find the longest well-performing interval. So the definition is that an interval of days for which the number of tiring days is strictly larger than the number of non-tiring days. So this means for this interval 996, so this means the well-performed is 2, and the tiring days is 1 because it is less than 8. So 2 minus 1, it is 1. Yeah. So it means it is more than 0. It is strictly larger than the number of non-recurring days. Yeah. So the recurring days is 9. 9 are recurring days, and 6 are non-recurring days. So this meets the condition. So the result is going to be 3. But how can we solve it? Basically, we need to use the ON time. ON square may not work. Yeah, this means we cannot use brute force. Maybe we can use a prefix sum, and by using prefix sum we can use ON square, but I'm not sure if it can pass. But actually this problem can be optimized. So for example, how can we use a prefix sum? We're going to prepare a prefix 0. This is just a padding at the left side. Yeah. Now let's just prepare the operation of each of the numbers. Let's just copy the array. So if we have an array like this, how can we calculate the interval and meet the conditions? Yeah. So we're going to turn these numbers. So for example, if it is more than 8, we're going to turn these numbers to 1, and 9 to be 1, and 6 to be minus 1, and 0 to be minus 1 because it is less than 8, and 6 minus 1, and another 6 minus 1, and 9, it is 1. Yeah. So what happens for this one? So this is easy for the prefix sum. Yeah, this is just prepared for the prefix sum. And then we're going to use a prefix sum array. And we're going to prepare a padding with 0. And the first number is going to be 1, and then it's going to be 2, and then 1 plus 1, 2, minus 1, it is 1, minus 1, it is 0, and then minus 1, it is minus 1, and minus 2, and minus 1. If we do the prefix sum, we're gonna get this kind of prefix sum. So I'm gonna call it prefix. If we can get a prefix like that, as you can see, the first one is padding, and this is 1, and this is 2, 1, 0, minus 1, minus 2, and plus 1, minus 1. And we can use so for example, this index minus this index, we can check if it is okay or not. Yeah. So let's just check. For example, we can check it like this. For this this index, so the number is 1, but here it is 0. So 1 minus 0, it is 1. It is more than 0. It means it is a well-performing interval. So the distance is 3. We can get the result. Yeah. And this is ON squared time up to now, because we just need to enumerate I and J in 2 for loops, and inside the 2 for loops we can check the distance. If, for example, this prefix I minus prefix J are more than 0, so our result is I minus J. So that's going to be our result. Yes, but this is ON square. But up to now, we will not use ON square. We're going to try to solve it in ON time. The ON time is similar like what we did in the monotonic stack. We just need to check for the right side. From the right side, we want to find a value. So for example, this value is 1. And for the left side, we're going to find another value which is smaller than this number 1. And we know that in monotonic stack, we can do it in ON time. Yeah, we just need to keep a monotonic decreasing stack from the first number. We're gonna keep a monotonic decreasing stack from the first number. Yeah, we're gonna put the index. This is 0. Maybe this is 1, 2, 3, 4, 5. We're gonna put 5 and 6 inside. So we're gonna put index 0, 5, and 6, and the number is just 0, minus 1, and minus 2. Yeah, we're gonna put these numbers inside of the monotonic stack. It is decreasing, and then we're gonna check from the right to the left side. So for example, this is minus 1. Minus 1 is more than minus 2. So what is the distance? The distance is yeah, let me check. The distance is 2, right? Minus 1 to minus 2. The distance is 2. Yeah, so up to now our result is 2, and minus 1 and minus 1, it is equal, so we don't count it, because basically we want to get the result more than 0. Yeah, so yeah, if it is more than that, so we're gonna take the value and we're gonna pop it out. If it is equal, we don't do anything, and then we're gonna check the next number. It's gonna be minus 1, minus 2, because we are checking from the right to the left side. So if minus 2, we're gonna compare with minus 1. Minus 2 is we want to check the numbers. Let me check. Yeah, it should be more than 0. Minus 2 minus 1, it is minus 1 less than 0. We will skip it, and then we're gonna check minus 1. Yeah, we're gonna skip it, and then we're gonna check 0. 0 minus minus 1, it is more than 0. It is 1. So we're gonna check it, and the index, we're gonna check the distance. So this is 0 to minus 1. Yeah, so the index from here, 0, 1, 2, 3, 0, 1, 2, 3, 4. Yeah, this is a yeah, this is a 4. Yeah, and then yep, then we're gonna check this 1 and this 2. And for example, this 2, this number, yeah, let's check the number 1 first. Yeah, let's just check this number 1 first. So this is index 3. So this number 1 is more than minus 1. Yeah. So what is the distance? Yeah, I got quite. So this 1 is more than minus 1. But we can have a distance, it is 2. This is 0, minus 1, and minus 2. This is the index 5 and 6. We're gonna use the minus 1 to check the result. Yeah, it means it is not inside. If 5 and 6, this one should be more than this, more than this number. Yeah, it is okay. More than 9 is more than 6. Yeah, if this 9 more than 6, it means we have a result of 1 for this minus 1. and we pop out this -2, and then we're going to compare with next. So if it is this -1 is less than or equal to this -1, we will ignore it. Yeah, let me just start coding. So if there's anything I need to explain, I'm gonna start to explain. So I would to prepare a prefix sum. Basically, the prefix would be starting from I'm gonna put a 0 index inside. Basically, at least I would to have an index 0, and length of the nums is n, and I would to check. So for I in range from the first index to n, if if nums if hours, let me first prepare the hours array as a -1 times n. So let me first prepare the prefix array. So for 8 in hours, I will use for I 8 in enumerate so for I 8 in enumerate the hours. If this 8 more than 8, so the prefix I should be 1. So inside the prefix it is -1 and 1. Now I would to prepare the prefix. It's going to be the list accumulate the prefix with initial value of 0. Now I would to print out the prefix. Let's check what is inside. Now let me give a random return at the moment, maybe just 3. Let's just check what is the prefix. Let's just check the first example. What is the prefix? So the prefix is like 0, 1, 2. I think that is why I did it wrong. Maybe my example I did it wrong, because this is 1, this is 1, and 0, 1, 2, 1, 0, -1, -2, -1. It is right. As you can see, the prefix is exactly the same. Now I prepared the prefix. So I just want to compare two values from the right side, which is bigger than the left side. So first of all, I want to put it inside a stack. So I'm gonna prepare a stack. So inside I will prepare the first index, and now I'm going to check the prefix. So from 1 to length of the prefix. So if prefix with this I is less than the value inside the stack, so it's going to be the prefix with a stack -1. I want to put it inside the stack. So stack should append the index. Now let's just check what is inside the stack. So inside the stack, let's just use the first testing case. It is 0, 5, and 6. Now we are going to check from the right to the left side. Yeah, so from the right to the left, if this number is more than the number inside the stack, so we're gonna check the distance. Maybe from here, this -1, for the index 6, it is at -2. It is more than that, we're gonna record the distance as 1. Yeah, because we use the prefix sum, just to use the index j minus index I, so the distance is 1. And then we're gonna pop this out. Yeah. Not pop out the prefix. Let me use a stack to explain. So the stack would equal to our stack. It is 0, 5, and 6. Yeah. So I want to check it from here. So the prefix and stack, we're gonna check it like this. So first one, it is a -1, and the stack for this 6, it is -2. So what I'm gonna do, I'm gonna pop this 6 out and get a distance of 1. Yeah, and then I'm gonna check this -1 with this 5. The index 5 is -1. It is equal, so I will not do anything. Yeah. Now I finished this one, and I am going to check with this -2. Yeah. So -2 is less than the -1. It is okay, so I will not do anything. And then I'm gonna check the -1. So -1 is equal, I will not do anything. And then I'm gonna check 0. 0 is more than 0 is more than this -1. Yeah. Yeah, but the index, as you can see here, but the index of the -1, it is 5. But this is 0 at the left side. It means it goes out of the boundary. Yeah. But what are you gonna do? If I go out of the boundary, I still gonna pop out this 5 because 0 is more than -1. Even though I get only one number, I still pop it out. And then I'm gonna compare with this 0. So 1 is more than 0. I'm gonna check the distance. It is 3. 2 is more than 0. I'm gonna check the distance. It is 2. And 1 is more than 0. The distance is 1. Yeah. So let me just finish the monotonic stack part. So for I in range, we're gonna use the length of the prefix -1. Yeah, because the prefix is equal to n plus 1. So here I gonna use n -1 and -1. Yeah. So up to here we are going to check while something inside of the stack, and my number is prefix with this I. So my number is more than the prefix, so it is inside of the stack. The prefix stack -1. Yeah. If it is more than that from the right to the left side, I'm gonna pop out at first. So this would be equal to stack.pop. And I will record the result. It's gonna be the maximum of the result with this I minus j. And finally, I'm gonna return this result, and I need a result to be 0 from the beginning. Yeah. So this is gonna be the process. Let me just run it to check if it is okay. As you can see, it works. But let's just print out something. I mean, for here, this kind of tag, maybe, yeah, because this I and j, maybe I and j, I should be less than j. We just check what happens for this I and j and I minus j. Even this I less than j, it is still okay because it is a negative value. while we are checking the negative distance, it is still okay. This is while we are checking like 0, 5, and 6 with this number. If this I is less than j, we get a negative distance. So I minus j should be a negative distance. So it should be okay. This is just the boundary check. It means go out of the boundary if we get a negative value. But we compare with the maximum result, so it should be okay. Yeah. Now let me just run it. Let's just check I minus j for the first example. As you can see, there's a negative 1, but we will ignore that because we check the maximum value. Basically, we're gonna get this 3. Yeah. Now let me delete the print areas and try to submit it to check if it can pass for all testing cases. Yeah, as you can see, it works and it's pretty fast. I think the difficult part is we're gonna prepare a prefix sum. I'm not sure if we can use O(n) squared to pass, but I think the best way is to use O(n) time, because monotonic stack is specially designed for this kind of a pattern. It means if there's a number at the left side, and we want to find a number at the right side which is bigger than this number, and we want to calculate the largest distance, and basically we can use a monotonic stack. So we're gonna prepare a monotonic decreasing stack, and then from the right to the left we're gonna check the numbers one by one. So if some numbers go out of the boundary, for example this is I and this is j, yeah, it is still okay for us because it is a negative distance. We will ignore that. I think that's for it. Thank you for watching. See you next time.